I'm Tom at the Rusty Rivet. All right, today we're doing real quickly. We're going out. I had a question about how clean an inverter predator generator, how clean the energy is. Some of you might not know that the energy has to be clean to run an inverter welder, anything computerized. You should not be running anything on dirty electric. Well, what has dirty electric? All right, my Miller Bobcat has dirty electric. Matter of fact, I hooked it up the other day. The second I hooked it up, it blew up. On the back of my truck, it caught on fire. All right, it started idling weird. The stator burned up. It melted down, actually burned a hole through the battery. This is all next to my acetylene tank on the end of my welding truck. Rest in peace, Miller Bobcat generator. I don't know. Unless someone has a generator, the actual whole generator that fits inside the Miller Bobcat 250, I would be grateful if you had one with a blown motor. All right. I can't seem to find one. It's almost more to fix it than it is to buy a whole generator, a whole Miller Bobcat with a couple hundred hours on it. It's quite ridiculous. Anyways, I'll quit belly aching. Let's talk about clean energy. All right. How do we test it? We test total harmonic distortion. If you look at a sine wave going up and down, nice and smooth, up and down, all right, you will see little jagged edges on a generator usually, all right. Typical household current, I just measured mine inside the house and it was 2.5% total harmonic distortion. So that's off of our power lines. So let's go out to the generator and check it out. Okay, we're out here at the generator. I have the Amprobe Nav50 set up to read percent total harmonic distortion. This was an expensive meter. That's one of the things I mean about running one of these channels. This cost me $450 for this meter just so I could do an episode for you guys. So please help me out. 1.6% total harmonic distortion. And this is a Predator. I believe this is the 11,500 watt Predator generator. Pretty cold. It's pretty cold up here in upstate New York. We're getting ready for another snowstorm. The snow just almost melted. All right, so let's talk about electricity quick. I don't want to bore you to death. All right, we're using an Amprobe Nav50, expensive meter. This is about $450, maybe a little less than that. There's not many meters that will test for this. That's one of the things about keeping the channel going. I need people to share and subscribe so I could get this stuff. I paid for this out of my pocket. YouTube's doing anything but making me rich. All right, so here we go. I think it was a 1.6 out here. My house was 2.6. All right, so it's actually cleaner on the generator than it is the house. One of the things I'm finding out about generators, the more I research it, some of them under load get cleaner, some of them under load get dirtier. If you have someone running angle grinders on the same generator that you're trying to run a welder on, that's a concern. If it's just you using it and you shut off your welder while you're grinding, I think that's okay. One of the things that we're not measuring so much on total harmonic distortion is we're not measuring voltage spikes. And as you go on and off with an angle grinder, I would think that would cause a heck of a voltage spike. All right. Also, if you're using an underpowered generator, then I think that it would be more prominent that if you hit the angle grinder, it could cause the motor to rev. If you hear that motor revving up and down, that's changing the current. That's changing that sine wave. All right. So you have to consider about all of that. All right. The formula to find out what you need to know is volts times amps equal watts. All right. And I'll try putting it right on the screen. Volts times amps equal watts. And if you put it in what's called the magic triangle, it's super easy to figure out. And my kids are like, my students at school, they're like, oh, the magic triangle. I talk about it a lot. It helps us all the way through math. I said math. That math class, that's important, especially if you want to be a welder. There's trig, there's volume, there's area, there's current, there's resistance. There's a lot of stuff in math class that we got to figure out that pertains to welding. So if I have, real simply, if I have a 120 volt welder pushing 30 amps, that would be 30 times 120. Let me do the math. That would be 3,600 watts. I usually use my calculator on my phone. Guess what I'm recording with. All right. So if you're running a 7018 rod, 1/8 rod at 120 amps, and you're on, let's say you're doing about 20 volts to keep the math simple at the stick. How do you increase your voltage with stick welding? Well, you increase your voltage by drawing that rod off of the metal. The farther off the metal, the more voltage you're going to get. So 120 amps, 20 volts is 2,400 watts that we're putting out. So we're going to at least be drawing in 2,400 watts into the machine, because no machine is 100% efficient. It's going to lose energy to sound. It's going to lose energy to heat. It's going to lose energy in the system. All right. So it's going to be more. And the other thing we need to talk about is a lot of these budget machines don't have what's called, and even some of the higher end machines don't have power factor correction. Say this is rated, say this little welder next to me is rated for 20 amps input. All right. If it does not have power factor correction and we have inrush current, that could be up near 233 amps. If you don't have that power factor correction, it could spike up higher and it could really slow down those generators. So run any machine you want at your own risk. As you can see, I have an overpowered generator for anything I'm running in here at 11,500 watts. It's cleaner than my household current. It's a pretty good scenario. One thing you don't want to do is run your welder on a weak generator. You want to go overboard with that generator. Much more power than you need, because when you dip down on current and it starts revving, you're going to get voltage spikes. You're going to get more harmonic distortion. All right. So science class is over. Obviously, math class is over. I don't have my calculator. All right. Don't forget to tune back into the Rusty Rivet. I hope I helped you out in the generator question. I know a lot of these machines. I know the Everlast machine, I was on the forum, and they said 3%. They want to keep it under 3% total harmonic distortion. My household current's 2.6. You're borderline. And remember, a power spike, that's a severe harmonic distortion. It's not really harmonic, but it's severe distortion to that sine wave. So anyways, I promised you science class is over. But please help me out. Please subscribe. Please like and share and send me a comment. Those comments really help. All right. I hope I wasn't off with my math. All right. We'll see you again on the Rusty Rivet.